Finally, NASA opened the spaceship that contained the largest asteroid sample ever collected by a space mission. The sample came from Bennu, a potentially hazardous asteroid that resembles a time capsule from the early solar system. On September 26, 2023, scientists at NASA's Johnson Space Center in Houston, Texas, removed the sample return canister cover from the OSIRIS-REx mission. The mission had brought back an asteroid sample to Earth 2 days earlier. When the lid of the canister was lifted, scientists were shocked to observe a covering of black dust and debris on the avionics deck. The sample's weight was also 100 grams more than what was gathered at Bennu. This was surprising because the sample had been kept secure in a sealed container the entire time. So, how did this initially come to be? What could be causing the sudden black dust on the canister's avionics deck? What, above all, do scientists hope to discover from the thorough examination of the biggest sample of asteroid returns to Earth to date? 3 main objectives guided the launch of the OSIRIS-REx mission on September 8, 2016. Sampling was the first step. In order to provide essential material for scientists to research and comprehend the composition of primitive asteroids, the mission's goal was to gather pure samples from the asteroid's surface. Characterizing asteroids was the second. The mission's objectives included mapping Bennu's surface, determining its composition, and assessing the asteroid's potential as a resource for upcoming space exploration. Astronomers were interested in learning more about the asteroid's geology. The assessment of the Earth's impact hazards constituted the third major goal. Bennu is a potentially dangerous asteroid, as was previously mentioned. September 25, 2135, is when Bennu will pass near Earth. Bennu's course will be altered by the gravity of our planet, making it difficult to predict its destiny. This is due to the fact that non-gravitational forces like the Yarkovsky effect have the ability to drive asteroids around in addition to gravity. The day side of a revolving asteroid warms up as sunlight reaches it. The night side of the asteroid cools and releases heat as it rotates. This produces a slight thrust on the asteroid, which can cause it to change course over time. The Yarkovsky effect is difficult to model, yet it can have a significant impact on where asteroids land up. We don't know where Bennu will be as it reaches Earth in 2135 because we don't know how the Yarkovsky effect will affect its orbit. As a result, scientists must explore a variety of probable trajectories, depending on how strongly the Yarkovsky effect pushes on Bennu. Several of these trajectories intersect with regions of space known as gravitational keyholes. If Bennu passes through a keyhole, Earth's gravity will modify its path just enough to induce an impact on a later orbit late in the 22nd century. The chances of this happening are relatively low, but scientists want to know as much as they can. The journey to Bennu took 2 years and 4 months. OSIRIS-REx arrived at its destination on December 3, 2018, after traveling nearly 1.4 billion miles, 2.2 billion kilometers. It entered orbit around the asteroid, launching a series of surveys and mapping operations to determine the best location for sample collection. The sample collecting event, which took place on October 20, 2020, was the most exciting aspect of the OSIRIS-REx mission. To acquire the sample, the spacecraft utilized its touch-and-go sample acquisition mechanism, or TAG-SAM, which briefly touched the surface. TAG-SAM is a robotic arm connected to the spacecraft's main body that collects asteroid samples and deposits them in the Earth return vehicle. Because Bennu is a small asteroid with a diameter of only half a kilometer, the arm had to acquire the sample in virtually zero gravity. OSIRIS-REx had only one shot, and there was no room for error. Finally, when the spacecraft made contact with Bennu at a location known as Nightingale, it employed a burst of nitrogen gas to agitate and pull surface material into the sample collection chamber. The sample size needed to be at least 60 grams. OSIRIS-REx, on the other hand, collected 300 grams of the material during its brief 9-second encounter with Bennu. This is 5 times what NASA had predicted. The sample was encapsulated, but there was an issue. Material was leaking due to a jammed flap created by larger boulders. To avoid further loss, NASA chose to forego the sample's scheduled measurement and seal it for return. On May 10, 2021, OSIRIS-REx departed Bennu and began its journey back to Earth. After nearly 2.5 years, the spacecraft arrived in Earth's orbit on September 24, 2023, and released the capsule containing the asteroid sample. At a speed of 12 kilometers per s, the capsule hit our planet's atmosphere and released a parachute to slow its descent. The spacecraft landed safely at the Utah Test and Training Range, where NASA officials recovered it. Scientists at NASA's Johnson Space Center in Houston lifted the lid on the sample return canister from the OSIRIS-REx mission a few days later. They were confronted with an unexpected and exciting sight. The first thing they noticed was a layer of dark powder and sand-sized particles on the avionics deck of Bennu's sample canister. This dust not only coated the interior of the canister, but also extended to the exterior, including the avionics deck, which contained the electronics. The discovery of these chemicals on asteroids shows that the components for life were there in the early solar system. A particularly fascinating example is the discovery of organic compounds on the asteroid Ryugu. Ryugu is a carbonaceous asteroid, meaning it is abundant in organic material. The Japanese spacecraft Hayabusa 2 returned samples from Ryugu to Earth in 2020, and scientists have since studied these materials and discovered a wide range of chemical substances, including amino acids. Amino acids are the basic building blocks of proteins, which are required for life to exist. This suggests that the building blocks of life may have arrived on Earth via asteroids in its early history. The OSIRIS-REx mission's next phase, dubbed OSIRIS-APEX, will focus on the asteroid Apophis. Apophis is a near-Earth asteroid with a diameter of 1,100 feet, 340 meters. It will make a near encounter to Earth in 2029, with a 1 in 150,000 chance of colliding with the planet in 2068. OSIRIS-APEX will arrive at Apophis in April 2029, just a few months after Apophis's near encounter to Earth. The spacecraft will spend 18 months in orbit investigating Apophis. During this time, OSIRIS-APEX will picture and map the asteroid, examine its composition, and estimate its size and shape with its instruments. The OSIRIS-APEX project is an important step forward in our understanding of near-Earth objects and the dangers they represent to Earth. The data collected by the expedition will assist us in better protecting our planet against asteroid impacts. The James Webb Space Telescope just uncovered the secrets of Earendel, the universe's most distant solitary star, which lies at the frontier of time. If you missed what Webb discovered, be sure to read up on this important discovery.